Hello everybody, welcome Public Inventors. I wanted to talk about a little project I've been working on. This is really just an experiment. It's not nearly close to being ready. I've been attempting to make an inexpensive linear position sensor to go along with the GLUS invention that I'm trying to make, which would allow a person to just hold something in their hand and squeeze it in order to control the GLUS pot. And the idea here is that I would build a tiny model of the GLUS structure and allow you to manipulate it with your hands, and then using radio communication, the larger robot would move in the same way. And so what I have done here is 3D printed a bellows. This is a bellows structure using the material called Ninjaflex. This is actually semi-flex. They make two materials. The true Ninjaflex is so soft it's very difficult to print with, so I use this harder thing. And as you can see, it bends quite a bit, and it's kind of squishy. Following a gentleman named Mikey77 who has been trying to make soft robots, I did this, and I used the system that he recommended, using this glue thinned with methyl ethyl ketone, and coated the whole structure twice, and finally got it almost watertight. I then mixed up a saline solution and injected into it, using a hypodermic syringe, the saline solution. The result was that since the saline solution conducts electricity, we can measure, using our voltmeter, the resistance of the system, and we can observe that it changes a bit as we bend it or as we compress it. And my hope was that this would turn into a linear position sensor. It's really far away from that. So as I let go, the resistance should go up. It has a problem that it actually still has a leak, so the resistance is going up as it relaxes here. If I squeeze it again, the resistance should go back down to 200 kiloohms or something like that. It should. Obviously, it's not super reliable at the moment. But it does change a bit as you change the structure of the system. One problem I have, as you can tell from the stains on my thing here, is that if you squeeze it very hard, the salt water comes out. So I attempted to join it together with epoxy here. That obviously has not worked successfully, so I'll probably have to re-inject salt water in there. It's not clear that this is really a practical approach, but the reason one would want to do it is that you could actually 3D print multiple units together and simply put the electrodes in there. I put these jumper wires in by heating them with the soldering iron, and that makes them hot enough that they push right in to the Ninjaflex material. And so I can't say it's been very easy to use, although certainly Mikey77 of Instructables has done a great job explaining what he has done to try to seal it up. But that's just an experiment that I'm working on that could be considered a combination of 3D printing and soft robotics, and hopefully will apply to the GLUS robot, which I am also trying to make. This is kind of a public service announcement. It's not particularly interesting, but at Public Invention, we try to document everything we do. Everything is open source, and we try to be as transparent as possible. So occasionally I post videos like this one, which are not very exciting, but are merely documenting what I'm working on. Thank you.